Good afternoon, everyone. My name is Francisco Hernandez, and today I'll be presenting my software engineering project titled Split Smart, a group expense sharing system. This project focuses on designing the system architecture and workflows for a shared expense tracking application using UML modeling techniques. Over the next few minutes, I'll walk you through my project step by step, including the features of the system, the UML diagrams I created, and how each part fits into the overall system design. Okay, this is my table of contents. Going straight into my introduction. SplitSmart is a group expense management system designed to simplify the process of tracking, splitting, and settling shared costs among multiple users. Whenever managing bills for roommates, group trips, or collaborative projects, SplitSmart enables users to create expenses, assign amounts to involved participants, and keep track of payments and balances over time. The system provides essential features such as group creation and management, equal and percentage-based expense splitting, overall workflows, and real-time balance tracking. Users can log on, manage their profiles, upload receipts, and receive notifications for actions that require attention. This report documents the system design and development process using UML. These diagrams include use cases, class, sequences, states, and activity diagrams, each with explanatory descriptions to represent the system's functional and structural behavior. The goal of this document is to provide a clear overview of the system, architecture, and workflows for both technical evaluation and future implementation. The first part of my project involved identifying and modeling the functional requirements of the system using a use case diagram. The system supports a wide range of functions. Users can sign up and log in, update their profile or reset their password, create and manage groups, add and remove members from these groups, create, edit, and delete expenses, approve or reject shared expenses, record payments, view balance summaries, generate expense reports, and receive notifications for activity like new expenses or payments. These use cases were then written out in detail in the form of user scenarios that helped me better understand how users would interact into the system from start to finish. I also have some non-functional requirements. In addition to what the system should do, I also define the qualities the system should have. These are the non-functional requirements. Some key examples include validating user input to prevent invalid entries, delivering quick response times under 2 seconds, ensuring secure authentication using hashed passwords, scaling up to support to 100 group members, providing a clean and intuitive user interface, storing uploaded receipts securely, sending notifications in real time, ideally within 5 seconds of an event. These requirements make sure that the system is not just functional, but also fast, secure, and user-friendly. I'm going to continue on to my class model. The class model for SplitSmart defines the core structures of the system's data and logic. It includes several interconnected classes that represent users, expenses, groups, payments, and supporting features like approval, workflows, and notifications. At the heart of the model is the user class, which contains user account data and is associated with one or more group objects. Each group holds a list of expense objects and tracks group membership, allowing users to collaboratively manage shared financial responsibilities. The expense class stores all relevant information about a transaction, including the amount, description, date, involved users, and an optional receipt. It supports equal and percentage-based splits and connects to the approval request object to manage approval workflows. Once an expense is submitted, Group members can approve or reject it, and the expense status updates accordingly. The payment class allows users to record transactions that help settle the balances. Each payment includes the payer, payee, amount, and date, and directly affects balance summaries. Notifications are handled by the notification class, which alerts users about events such as new expenses, approvals, and payments. To support clean separation of concerns, the model includes control layer classes such as DAO Manager and Expense Controller, which coordinate between the user interface and the data layer. The expense page and payment page serve as boundary objects representing user interfaces in the sequence diagram. Overall, the class model supports all systems use cases and serves as the foundation for the application's behavior, as demonstrated in the accompanying sequence, state, and activity diagrams. These are my sequence diagrams. I'm going to start off with the create expense. This sequence diagram illustrates the interaction between the user interface, control, and entity objects involving creating a new expense. The process begins with the user submits an expense form through the expense page interface. The request is passed to the expense controller, which creates a new expense object and sets its attributes based on the user input. Once the expense is populated with the necessary details, amount, description, participants, etc., the controller moves the manager to save the expense to the database. After the save operation is successful, the system notifies the involved users and displays a successful message to the creator. My record payment sequence. This sequence diagram models the process of recording a payment between users within a group. The interaction begins when the user enters payment information such as amount, payee, and method on the payment page interface. The request is forwarded to the payment controller, which creates a new payment object and sets its details. The controller then calls the DAO manager to save the payment to the system's data layer. Upon successful saving, the controller updates the relevant balances for both the payee and payer. The system then provides confirmation feedback to the user via the user interface. Moving along to my state diagrams, I made one for my expense class. The state diagram illustrates the life cycle of an expense object in the SplitSmart system. The expense begins in the draft state when initially created. Once the user submits it for review, it transitions to the pending approval state. From there, the expense can either be approved if all involved users accept it or reject it if at least one participant denies it. Additionally, the expense can be canceled at any point before final approval. Each state transition is triggered by specific methods such as submit for approval, approve, reject, and cancel requests, which align with the operations defined in the class model. The diagram clearly demonstrates how the system enforces approval logic and ensures that only confirmed expenses affect group balances. So you could see that it starts off as the draft, and then when it goes to the pending approval, it's either going to get rejected or approved by the user. If it's rejected, you could go back to the draft and create another one. But if it's approved, it automatically goes to, you've pretty much finished. My approval request state diagram. This state diagram represents the life cycle of an approval request object associated with the submitted expense. The approval request starts in the created state and transitions to submitted once it is set in the required approvals. While in the submitted state, each user can either approve or reject the request. If all required approvals are received, the request transitions to the approved state. If any user rejects it, it moves to the rejected state. showing right here. If it's submitted and approved, it goes to the approved state. If it's rejected, it'll go straight to the rejected state, and then it just finishes. There's no going back to the created. My payment state diagram. This state diagram outlines the different states a payment object can move through in the system. Once a user records a payment, it begins in the pending state. The system then processes the payment, and based on the result, the state transitions to either confirmed or failed. In some cases, the user may cancel the payment before it is confirmed, leading to a transition to the canceled state. Each state changes is triggered by specific operations such as confirm payment, the fail payment, and cancel payment. This diagram highlights how the system handles payment verification and ensures the integrity of financial records throughout the process. So this would be a pending payment, and then it could either go to one of these three states, being confirmed, failed, or canceled, and then it just finishes. So we're moving along to my activity diagrams. This is my create expense diagram. So this activity diagram outlines the step-by-step process a user follows to create a new expense. The process begins with the user filling out an expense form, followed by system-side input validation. If the input is invalid, an error is displayed, and the user must revise their entities right here. If it's not valid, boom, ends over here. If it is valid, the system creates an expense object, sets its attributes, saves it to the database, and optionally notifies the involved users. A success message is then shown, concluding the process. The diagram captures the core workflow and key decision points of the expense creation process. So this is kind of a successful process right here. Starting with the user is going to go to the expense handling page, fill it out, and then it's either going to be validated, yes or no. For my record payment, the user logs in, fills out the payment form. It's going to be validated. Is it validated or not? If not, it shows an error message. If it is, it creates a payment object. So I got to set the attributes, and then if everything's going good, it sends a notification, saves to the database at the same time. Had to use the fork join because these are going at the same time. Updates the balances, and then shows confirmation message, and then boom. This diagram model is the workflow of recording a payment made between users. The process starts when the user enters payment details through the interface. The system validates the input and either shows an error or proceeds to create and save a payment object. A fork is used to represent two simultaneous actions, saving the payment and sending a notification to the payee. Once both tasks complete, the system updates balances and confirms that action to the user. Pretty much what I explained. Adding a member to the group. This diagram represents the process of adding a new member to the group. After navigating to the group management page and selecting a group, the user opens the add member form and inputs the new member's details. The system validates that the user exists and is not already part of the group. Validation fails, an error message is shown. If successful, the user is added to the group and notification was optionally sent. A confirmation message is then displayed, completing the flow. So when the user logs in, they open the group management tab. They select the group, add member, new member, validate member. Boom. Is the user a valid user? No. Straight error message, ends it. Adds it to the group if it is a valid user, notifies the user, show confirmation message. Okay, concluding my report, throughout the development of SplitSmart, the use of UML modeling provided a structured approach to designing and understanding the system. From the initial use case definitions to detailed class and behavior diagrams, each modeling step helped refine both the functionality and architecture of the application. This project not only demonstrates the technical structure of a shared expense platform, but also highlights the importance of planning, iteration, and clear communication in software design. The process has strengthened my understanding of system analytics and UML best practices and prepared me to build scalable, user-focused applications. So now I want to show you my project in Enterprise. So starting off with my user cases, right here, this is my actor. The actor is going to log in, and then there will be 4 pages, not 4 pages, but 4 options kind of in the main menu. They can select through the account and authentication. That's going to let them go update their profile, reset their password, and log out. Expense handling, this is where they're going to be able to create the expenses, edit the expenses, delete them, split them with the other users, and it's going to send them notifications about the new expenses. Balance and payment tracking. Once a user is in here, they can generate the expense report, view their balance, and record payments made. That's where they could see kind of the proof of the stuff they've done. And then group management, this is where the user is going to be able to add new members, delete the group, leave it, remove members, and or create groups. This is my class model. It has the majority of the more important classes being the main manager, the approval request, expense, group, user. These are more of the important ones because the user has to connect to the group because the group pretty much is a user, and then that connects with expense, and all of these go through the main manager. Thank you for tuning in and listening to my project and report on my program SplitSmart. I hope you have a wonderful day. Until next time.